So we're going to teach you about regression and what to use. Regression is the study of relationship between data. So we'll give you two examples here. We'll say arm length and height. Yesterday, we looked at that data and we said that there is, without a doubt, a strong relationship that exists between those couple pieces of data. Everybody agreed? Good. So what else other than arm length and height? Here's another one. Temperature and heating bill. Now think about these two examples. If the arm length increases, what do you think happens with the height? It increases as well. If the temperature outside increases, what do you think happens to the heating bill? Goes down. So sometimes the relationship is positive, sometimes it's negative. Okay? Correlation is the measure of strength of the relationship. Measure of the strength of the relationship. Strong, weak, no relationship. Those are very vague words. In mathematics, we don't like vague terms. We like a precise definition. And so we subscribe to something else, which is your correlation coefficient. Correlation coefficient is an R value. It sits between -1 and +1. It measures the strength of the relationship of the data. So you can see R is equal to -0.9. You can see R is equal to 0.01. You can see R is equal to 0.68. Where does the correlation coefficient come from? It comes from looking at how well the best fit line fits the data. The best fit line is the line that best fits the data. We like to use it as a predictor. So we can say, hey, we see what this line does. We see the trend that's continuing. Yesterday we looked at your arm span, and we looked at your height, and using that data, we can make a general prediction of what the arm span of Taco Fall would be, who's like 7 feet 6 inches tall. So there we go. Properties of the correlation coefficient are. R is a value in the range of -1 to 1. It is not slope. R equals 1 would be an extremely strong relationship. Meaning if you were to plot the dots, they would make basically a straight, perfect line. That would be about an R value of 1. R value 0.5, it means that the data does trend upwards, but it means the data is much more spread out. So for example, in the first set, you could say, I can very easily draw a line through there. But in this one, like, how would you figure out where the line goes? I'm going to take a guess. I'm going to put it right about like that. Notice how these lines have the same slope, don't they? But their R values are different. Because the R values are positive, the lines both go up. But you can see how all this data varies from that spot. R value of 0 means that there is no relationship that exists among the data. Where would I even begin drawing a best fit line in that scenario? Man, I can't even begin to think of where I'd put it. You know, some people might say, well, it's easy. You just put it like that. Really? Well, if that one works, then why doesn't this one work? It seems to work just as well, doesn't it? And for that matter, if that one works, why doesn't that one work? Sometimes people make the mistake, they say, well, that means that you have a line with a slope of 0. No. It means that you can't draw a line to really fit that data. R equals negative 0.5. Again, you would have the same type of scenario as here, except the data would be trending down. I'm going to draw it with a slightly different slope so you understand it doesn't mean that the slope is 0.5. Okay, and draw the like this. So you can see if the data is very spread, if I were to draw the best fit line, I might try to draw something like that. 0.5 means that it's definitely scattered. Negative means it's heading in the downward direction. And finally, negative 1. Means that the data makes basically a perfect line. It's trending in the downward direction. Does not mean that it has a slope of 1 or negative 1. Between you and your people around you, I want you to talk about these 4 pieces that you see here. And I want you to do 2 things. Number 1, I want you to use the words strong, moderate, weak, positive, none, negative. Use some words to describe the what this data or what this R value would say about the data. And then number 2, I want you to try to plot some points. So number 1, describe. And number 2, draw data that would represent what you feel like that number would be. Go ahead, talk, share, go. And Cynthia, please don't just steal all of John's answers. Sir. No. I'm going to ask 4 different people to come on up here. And you can grab a marker. And you can make a plot for what you think. Somebody be brave. See Jack eyeing it up. Jack's like, I got this. Elssa's already got all 4 done. Coldness is a Buddy Carson. All right, we didn't have any takers, so I'll try. I'll point 4. I might put something like, I don't know, it definitely looks like it's trending. Got a few more in the middle there. It looks a little bit stronger. Seemed a little bit weak there. But I would try to have something where it's definitely scattered, but you can definitely see a positive direction. I would describe this as moderate or weak. Either one would be fine, and it's definitely positive relationship. This one here, I would be looking to see, if I ask this on the test, I'd be looking to see something like that, you know. Maybe have a couple points that are scattered, but this is very, very strong. Overall, you could definitely tell exactly where the line is going to go. This would be strong, and it would be negative. Negative 0.002 is really close to 0. So this is none. There's no relationship. There is no relationship. I wouldn't even go as far to say that it's weak. There's no relationship that exists at all. You should see data that's scattered anywhere that has no rhyme or reason to it. And then R 0.89, I would just want to see something that's maybe not quite as strong as that. So if I'm looking at your answers, I want to see something that's not quite as strong as that, but still very strong. Looks, you know, that will look stronger than that, I think, if we look at the dots. You need to make it not as strong, just put another one off to the side. And it's definitely positive. I would call this strong, positive. My good friend, Mr. Lucas, said, this question, we're going to put weak in the middle, and we would put strong over here. We put strong over here. So the further it is to the side, the stronger the relationship is. Everybody got that vision in their mind? Okay, take out your Chromebooks. Okay, in your Chromebook, you are going to click on the waffle off to the right-hand side, and you're going to click Sheets, and you're going to hit Blank Sheet, and you're going to title it Statistics, Regression, and then put your name on it. And then you're going to go File, and you're going to go Move to, and go ahead and move it on over into your Statistics folder. All good so far? Okay, now when we do this kind of work, we end up using a lot of different tabs because you're doing a lot of different regression. So I'm going to zoom in a little bit so everybody can see real well. But this bottom here, it says Sheet 1. That's where I'd like to create my different labels. So you could go ahead and just press Add Sheet, Add Sheet, Add Sheet, Add Sheet. That way you got room to do all the examples that you need to. And on this bottom tab here, if you right-click on that tab and hit Rename, that way you can put the type of problem that you're working on. So I'm going to put heating bill, and I'm going to put Tuesday 4/13. So that tells me, you know, kind of the day I was doing this project, and it also gives me the type of problem I'm working on so I know how to access the data. I'm going to pause the video right now. I'll walk around, just make sure everybody has this set up so we can execute it properly. Go on then. Look at what we see here, and the problem is we have, as I bring this up, it says, use the data relating the average temperature in a month to the heating bill at Claire's house that month. So you can see the average temperature, and you can see the heating bill. It says make a scatter plot of the data using the mean temperature as the independent variable. The independent variable we put on the bottom, the dependent variable we put on the top. Dependent means it's affected by the other. Independent means it is the cause. You tell me, do you think the heating bill changes the temperature outside, or do you think that the temperature changes the heating bill? Would we all agree that that's quite obvious in this situation? Whereas we talked about yesterday, the length of arms, arm span, and height, there's probably not a clear cut which one causes the other. So we might say height would be more dominant. I don't really know. I'd have to ask a doctor. I would say that neither one would be the dependent variable. So we would say in this situation, this is the independent, and this is the dependent variable. Okay, so that's what we have. That one goes on the bottom, this one goes on the top. So that just means that we enter it accordingly. So I've got to be able to switch back and forth. So we're just going to make two columns. And this will be the skill that you're going to want to be able to do for your next test, as well as your next worksheets and such. Okay, I'm going to go to my Google Sheet. Got it right here. And first thing I put up there, I put mean temperature. Second one I put up there, I put heating bill. And I type in my data. 38, 42, 44, 36, 42, 49, 38. For the heating bill, I've got 93, 79, 75, 83. Is there somebody at the door? Yeah, just let them in. E3, 74, 67, and 86. If you don't like the way those are situated, if you want to say, center them or something like that, you sure can. Not needed, but something I like to make my data a little bit smaller and bring it together. So that's my data. Any question on this so far? Okay, so if you notice what it says in the instructions are, it says, make a scatter plot of the data using the mean temperature as the independent variable. This is find the correlation coefficient and the best fit line. That's our next step. Display the data using a scatter plot and find the equation for the best fit line and the correlation coefficient. Here's how you do it. We grab the data. I'll try grabbing the labels and see what happens. Maybe we'll put those there as well. Anybody want to guess what I press? Insert chart. Very good. It tries to guess which chart. It said it grabbed a scatter chart. Is that what we want? It sure is. It said heating bill versus mean temp. It put the mean temp on the bottom, the heating bill on the side. Exactly like we wanted it to. It's a little bit bigger than I want. I'm going to make it smaller and drag it up into this area. There we have it. I'm going to walk, just make sure everybody's got a plot up there. The first step. Then you're going to have to be able to do this on your next test, be able to make your plot. The first step was to create a scatter plot. It used to be we would always just do this on our TI-83s, TI-84s. Now we have other options. What are the two things we said we needed after this? Correlation coefficient and best fit line. Hit this box right there. Grab Edit Chart. Go to Customize. And go to your series. As you scroll down, you can see that you can insert a trend line. And you could choose to show R squared. And furthermore, the label that you can choose is you can use equation. Those are all the things you want to click on. Trend line, use equation, and show R squared. Make sure you've got that, and then I'm going to bring you back here. And I'm going to need your help finishing this problem off. Best fit line. It was the heating bill is equal to, and what was the equation that it came up with? negative 1.68 times x. So negative 1.68 times x. Again, we used the temperature as our x variable. So negative 1.68 times the temperature. And then the other part of the equation was plus 149. We just leave the r squared off. We say that r squared is equal to 0.746. So if r squared is 0.746, what would we have to do to come up with r? Yeah, so when we take that 0.746, we take the square root of it, 0.746, and our r value is 0.837. What? 0.8637. Now, this isn't totally true. Our line, was the data tending down or was the data tending up? It was tending down. So when we take square root, we get to choose the positive or the negative. Should we choose the positive or the negative? The negative. Good. We've got our r value. We would say that there's a strong relationship here. It's negative relationship. We have our prediction equation. Now we can actually make our prediction. It says, predict the heating bill for a month in which the average temperature is 40 degrees. If you want to be able to predict the heating bill when the average temperature is 40, we simply plug 40 in there. Your bill is equal to negative 1.68 times 40 plus 149. Everybody should be able to take their equation and use it to make a prediction. Take out my calculator, negative 1.68 times 40 plus 149. $81.8. Now some of you guys are like, I don't want to go back and forth between my Chromebook and my calculator. So fine, go ahead and take your Chromebook and type it in there. Equals negative 1.68 times 40 plus 149. And there you have it, right there. We do the second part. We could make another prediction as well, but it says, how accurate do you think your prediction is? What do you guys think? Think it's fairly accurate? Yeah, I would say fairly accurate. And I say that because our R value is so strong as you look at the data. Okay, you try number 3 on your own. Go ahead. Work with a partner if you need to. And that's it for the day. We'll cover that last example tomorrow.